All right, good morning and good afternoon to everyone. My name is Jason Straight with the Cloud Pass Virtual Group. The presentation that we have today is Azure SQL Containers with Andrew Pruski. Before I hand things over to Andrew, I'm going to go over just a few announcements here just to cover a few things with the chapter or with the group. The first thing is that this presentation today is brought to you by our sponsor, Quest Spotlight Cloud. Spotlight Cloud is the first Azure-hosted database performance monitoring solution focused on SQL Server customers. Leveraging the scalability, performance, and built-in security of Microsoft Azure Cosmos DB, Spotlight Cloud combines the best of the cloud with Quest's engineering insights from years of building database performance management tools. If you are interested in presenting for the user group, you can, for the virtual group, you can do a couple things. First, you can email me at cloud@pass.org, and by doing so, I can get you set up on the schedule and we can get you all planned out. Or if you'd like, you can go out to the Pass website for the virtual group. That's at cloud.pass.org, and out there, there's a link that you can click on that will bring you to the Cloud Virtual Group call for speakers. This virtual group is part of a number of virtual groups that are out there helping to educate the PASS community. There's data architecture, DevOps, there's some language-focused ones, Spanish and Chinese. So there's lots of opportunity to go out and learn virtually through PASS. Throughout this session, if you do have any questions or if you have anything that you'd like to share, you can share your experiences in the chat that comes along with the GoToWebinar interface. Along with that, there is a Q&A panel, and on the Q&A panel, you can just type in your questions, and as we get to the end of the session, I'll bring those questions over to Andrew. And at this time, I'm going to pass things back to Andrew for his session today, Azure SQL Containers.
Thank you very much, Jason. Can you see my screen?
Yep, it's coming through perfectly.
Excellent. Welcome everyone to this session on Azure SQL Containers. A little bit about myself first. My name's Andrew Pruski. I'm a SQL Server DBA and Microsoft Data Platform MVP, originally from Swansea, Wales, but I've been living in Dublin, Ireland, coming on to 6 years now. My Twitter handle at DBA from the Cold and my email address, dbafromthecold@gmail.com, are on the slide there. So if you have any questions after today, please feel free to reach out. I'm always willing to talk about this stuff. My blogs are as well, dbafromthecold.com, posted multiple articles about running SQL Server locally and up in the cloud. So if you want to check those out, you're more than welcome. Some I'm using to base this session on, and some do go into a little bit further detail. And then finally, there's my GitHub account, github.com, dbafromthecold. All the code and the demos from this session will be posted there, and I'll give you a link to that at the end as well. So, onto the session. Containers are all the rage at the moment. And it's easy to see why. The ability to spin up SQL Server in a very short period of time has benefits for us SQL Server folks that we shouldn't be ignoring. And Microsoft have got some very cool technology up in the cloud that allows us to run SQL Server in containers. And so that's the aim of this session, to give you an overview of those technologies and see what they can do. So this is what we're going to be checking out. We're going to start with the Azure Container Registry, a private managed registry up in the cloud that we can use to host our container images. Then we're going to have a look at container instances. This is Microsoft's serverless offering to allow us to run containers in the cloud. And then finally, we'll have a look at Azure Container Services. This allows us to use an orchestrator to deploy and manage our containerized applications up in Azure. So we're talking Kubernetes. So first things first, the Azure Container Registry. Now this is a private managed registry that we can use hosted up in Azure to push our container images to. A little bit of terminology first. I always get these mixed up, so I'd like to clear these up. The first one is the registry. A registry is a service that stores our container images. If you've interacted with Docker, the Docker Hub is a container registry. And Microsoft's got their own registry as well, the MCR. And so that's all the Azure Container Registry is, a service that stores our container images. A repository is a group of container images that have the same name that are identified by tags. So if you have a look at the Microsoft SQL Server repository, you will see tags in there like CTP 2.4 2019 CTP 2.4 Ubuntu, CTP 3.0 Ubuntu. There's a whole bunch of images in there, and we identify those by the different tags. So the Azure Container Registry has a couple of cool features. We have encryption. All images are encrypted at rest. we have geo-redundant storage. This guards against a local regional storage failure. So if storage in a region goes down, we still have access to our images. The premium tier there has geo-replication, which guards against a total regional failure. So if our entire region goes down, we still can grab our images. And the final one there, ACR tasks. This is a really cool feature. It is a build service, and we can use things like webhooks to hook into, say, a GitHub repository. So if I push to a GitHub repository, say a change to a Docker file, this will automatically go off and build me a new container image. I mentioned the premium tier there, and there are three, well there are four. There's the classic tier, which has since been deprecated. There are three main ones now, basic, standard, and premium. And as you'd expect, as we go up the tiers, we get, say, more storage, more IOPS, more bandwidth. We have more webhooks. And then the final premium tier there, it has Geo the replication feature. So let's go in and let's start building an Azure Container Registry. Now I'm going to be using the command line, I've forgotten the Azure command line interface, the CLI, sorry, Azure command line interface instead of PowerShell. Just a personal preference, you can use PowerShell. There are all the equivalent commands for everything I'm going to be doing with PowerShell. The AKS module last time I looked was still in preview, but everything's there. And if you go on my GitHub account, you can have a look at the repo for this session, and there's three branches there. There's a Linux branch and a Windows branch. The Windows branch has all the PowerShell commands. But I'm going to run through using the Azure CLI. So the first thing we need to do is log in to our Azure account. So we say Azure login. And if we're using the legacy thing here, it'll pop up saying enter a code, drop it into the web page, and then we can log in. It's changed recently. If you just type in Azure login now, it will spin up a web browser, take you to the Azure portal and ask you to log in. You'll sign into your account and boom, you have logged into your Azure account. Once we're logged in, let's create a resource group. Let's create a resource group to contain all the objects that we're going to create. So we just say Azure group create, give it a name, containers1, and then specify a location. Now I like to use ECUS when I'm testing out these features, because when I first started working with this stuff, a lot of stuff was in preview and it wasn't available in all locations. But ECUS is generally a good bet if you're trying out new stuff. So we say Azure group create, name containers1, location ECUS, hit execute, and boom, we've created our resource group. So once that's up and running, we can then create our registry. We say Azure AZ, ACR, the keyword there, Azure Container Registry, create within our resource group of containers1, an ACR named Test Container Registry 01. And then we pick a tier at the bottom, SKU, Basic, Premium, whichever one we go for. This is my own account, so I'm going to go with Basic. And that is it. Hit execute, let that create, and we have created our ACR up in the cloud. Literally two commands, one to create a resource group, and then one to create our registry. So now we have our registry, we need to log into it. We don't need to pass any more credentials in. It'll take the credentials we used to log into our Azure account and log into our registry. Remember, it's a private registry, so only who we give access to can push images to our registry, including ourselves, so we need to log in first. So Azure ACR login, specify the name, and boom, we're logged into our registry. Okay, so we're now into our registry. Next thing we need to do is grab some details. Now we need to grab, this little login server here, so we need to tag our images that we want to push up with that login server name. So we say Azure ACR list. In our resource group of containers1, it's going to list off all our registries, but we've only got the one, so there we are, we have the information there. And we just need to make a note of that test container registry 01.azurecr.io, because we're going to use that to tag our images, so when we do a Docker push, it knows where to send them. Cool. So we have our registry. We have some details about it. We're logged into it. Let's go ahead and build an image that we can use to push up to the cloud. So this is a Docker file. First thing I'm going to say is, sorry, should explain. If you don't know what a Docker file is simply a file on your computer that contains a bunch of commands that, when executed, will build us a custom container image. I like to think of it, well, a container image was explained to me as the installed state of an application in a reusable format. They're baselines, essentially. They're baselines that we can use to build containers from. And all containers built from an image will be a carbon copy of all the other containers built from that same image. So here's our Docker file. And the first thing I'm going to do is say from mcr.microsoft.com MS SQL Server 2019-CTP 3.0-Ubuntu. This is Microsoft's 2019 CTP 3.0 Ubuntu image. So I'm going to base my new container image off Microsoft's image. Then I'm going to make a directory within my container called var opt SQL Server. And then I'm going to copy a couple of database files into it. Notice that there's no file path for these database files. There can be, but to keep the slide nice, I haven't included that. So that means these database files have to be in the same location as my Docker file. Next, I'm going to copy a script into that location that I've just created called attached-dbs.sh. Now, all this is going to do is create a database from the database files that I've just copied in when it's executed. There's a little bit of a trick to this, and I've been having some issues with it, if I'm honest, up until about half an hour recently where this hasn't worked, and I'll explain that in one of the demos later. But we're going to copy that script in, and then we're going to use some environment variables to set the default data, backup, and log directories of my SQL Server instance within my container. So the idea with all of this is that when we spin a container up from this image, not only am I going to have my database ready to go, I'm going to actually have SQL configured to how I want it to be as well. So I just have to spin the container up. I don't have to do anything else with it. I'll have databases there, and I'll have certain configurations set. Next thing, I'm going to make my script that I've copied in executable. And then finally, I have an entry point here where I'm going to execute the script and then spin up SQL Server. Now this is this little trick I was talking about, and Bob Ward talks about in his excellent Pro SQL Server on Linux book. And I will dive into exactly what that's doing in the demo coming up now. But essentially what's happening here is when the container comes up, it's going to execute that script and then spin up SQL Server for me. The idea being, once I log into my SQL instance, I'll have my databases there ready to go, and those environment variables will have set my default data, backup, and log directories. So we have our Docker file. Let's now build our image. So we say docker build -t, tag it with a name, test image, and then I specify a location to where my Docker file is. In this case, C Docker. Hit execute, and we can see Docker stepping through each one of those commands in my Docker file, building me my custom image. Great, we have our custom image. So now we need to push it up to the cloud. But the first thing we need to do is tag it with that login server name that we made a note of from our registry. And the reason for this is that when we say Docker push, it knows where it's going. So all we say is Docker tag test image, and then the new name here. So the image that we built, and that's now what was called test image, is now going to be called test container registry 01.azurecr.io dev SQL image latest. What this is going to do when it's pushed up to the cloud is within my ACR, create a repository called dev SQL image, and then identify this image with the tag of latest. And we can see here, if we do Docker images afterwards, test image is still there, but it's also presented with the new name here. We can see it's the same image with the image ID. So great, we can push it up to the cloud. And we can say Docker push test container registry 01.azurecr.io dev SQL image latest. We don't need to do anything else because we've tagged it with that login server name and we're logged into our registry. So that will automatically go up into the cloud, into our ACR. We can verify that once it's done by saying Azure ACR repository list, all the repositories in our ACR called test container registry 01. I'm specifying an output there of table. And there it is, our dev SQL image. Because we've tagged our image with the repository in dev SQL image, it's automatically created that for us. We can drill in further into that repository by showing the tags in there. And we can say Azure ACR repository show tags, name, test container registry, our ACR, and then our repository dev SQL image. And then for this one, I just have the one image there with the tag of latest. So let's go ahead and let's push an image up to an ACR. Okay, so I have Visual Studio Code here. If you haven't used Visual Studio Code, I highly recommend it. It's a brilliant scripting environment, and it's got some really nice plugins for Docker, Kubernetes, PowerShell, and the Azure CLI. Okay. Now, a while ago, Microsoft moved their images from the Docker Hub into their own registry, the MCR, and that meant we couldn't see the new images that were coming out. But there is a really nice little script that we can run to view those images because they've made it compatible with the Docker Hub catalog API. So if we run this and then do a repo.content, we can see all of the images. So we have pretty much all of them 2017 onwards, and there is the latest one there, 2019 CTP 3.0-Ubuntu. So it's really nice. A friend of mine, Rob Sewell's actually got a little script here that polls this and will inform him when new images are released. Really handy when Microsoft are releasing a new, I think it's a new CTP every month or so. Okay, so we have that. I'm logged into my Azure account. Let's make sure I'm logged into my registry. Let's not do that. There we go. So waiting for this to come back. Yep, telling me I'm login succeeded. And I can run a little script here as well, just to pull out that login server name of an ACR that I created earlier. So there's apregistry.azurecr.io. Okay, so I have my local images, and here is mcr.microsoft.com, MS SQL Server, the CTP 3.0, and I have my Docker file here. So I come in, there we go. Exactly the same as in the slides. So we're building from that image, making a directory, copying database files in, copying that script in, setting environment variables, making that script executable, and then setting the entry point to run the script and then spin up SQL Server. Now that seems a little bit counterintuitive. Why would I run a script to attach a database and then spin up SQL Server? Usually you'd spin up SQL and then attach the DB. If we have a look in the script, the first thing the script is doing is going to sleep for 10 seconds. And then it's going to create the database from those files that I copied into the location that we created in our Docker file. Now the reason for this is that containers always need an active process running. So if I had this the other way around, if I started up SQL and then ran my attached database script, SQL would spin up, attached database script would run, this attached database script would complete, and then the container would shut down. This way, the attached DB script comes up, waits for 10 seconds, that gives SQL enough time to spin up, and then the database is attached, and SQL stays running, and the container stays up. Now there are different ways of doing it. You can use a command. This is one way. There are certain issues with doing it this way, which I'm not going to go into now. I have been having issues with spinning this up in a ACI today. Another way you can do this is spin your container up, attach your database manually, shut your container down, and snap your container there. So the script's not going to run it, or you don't need to run the script. And that's what I did for one of my versions to make sure the ACI demo works. And I'll show you that in a little bit. But for now, let's build our image. So I'm going to say docker build test image to the location of my Docker file. Now you see Docker there stepping through each one of those commands and building me my custom image. And I get a warning there because I'm actually building Linux containers from a Windows host, so files and directories might be a little bit more open than I'd like. So if I was going to do this in production, I'd go ahead and change that. But for now, I'm going to leave it as it is. I can check my images. I should have my test image at the top here. There we go. Excellent. So let's make sure everything's working. Let's run a container locally to confirm. So I'm just going to say docker run -d, run it in the background, detach it, demonize it, however you like. -P mapping some ports, so I'm mapping port 15789 on my computer to 1433 within my container. So anything hitting that container on hitting this computer on 15789 will automatically be mapped to 1433 in my container. I can connect to SQL Server. Then I'm accepting the end user license agreement, which you need to do for every single time you spin up SQL Server in a container. Specify an SA password so I can connect. I'm going to give the container a name, and then I'm spinning it up from the image I've just built. Hit execute. And we're just waiting for SQL to spin up the container now. Excellent. Okay. I can make sure that's running by saying Docker PS. And Docker PS on its own will show all containers that are running on my system. -A will show any containers no matter what state they're in. So I'm just keeping them in just in case something's gone wrong. All looks good. So what I can do now is jump over, and this is Azure Data Studio, connecting to, remember, localhost 15789. And my database isn't there. Wonderful. This is the issue that I was having earlier. So it's actually in the container. What I can do is just run a create from those two files that I've created and hit execute. There we go. There is my database. If I come back here, do a refresh, my database is there. Now, I haven't had enough time to dive in and find out why that. It seems to be an intermittent issue. So what I'm going to do is come back. And to make sure this works, I'm going to say docker stop test container. And this is going to do a graceful shutdown of SQL Server in my container. Excellent. Okay, and then I can snap. I can say docker commit test container as test image 2. So I'm now snapping that stop container as a new image. And the idea here is I've already created that database there, so I don't have to rely on that script running anymore. That database is there in my SQL instance. So I can do is say docker tag test image 2, and then tag it with my ACR name, apregistry.acr.io. And I call this dev SQL image version 5. Tag it. And I can view my images. And at the top there's the first image that didn't work, and there's my test image 2 here. Okay. So I'm logged into my registry, so I can just do a push. Docker push apregistry.azure.io dev SQL image version 5. And I've already pushed some similar images up to the cloud, so it's realized that this image is made up of multiple layers. Some of them already exist up in the cloud, and it's just pushing the different ones up. And there we go, already done up in the cloud. Do it clear. Look, there's my dev SQL image repository. And let's have a look at the tab in that repository as well. There we go. So I've already pushed latest v1, v2, v4, and we just pushed up v5. If I jump into the portal, here's my registry here in my resource group of containers 1. You can dive in. Go to repositories. Here's my repository, my dev SQL image, and there are all the images with their tags under that repository. Okay, so minor issue, but we can work around it with that script. So we've snapped our container with our database already created an image from it, tagged it with our ACR login name, and pushed it up to the cloud. Minor tidy up there. Great. Okay, so now we have that image up in the cloud. Let's do something with it. And the first thing I want to show you is Azure Container Instances. Now this is Microsoft's offering to allow us to use, Microsoft's serverless offering to allow us to run containers up in the cloud. So we don't have to worry about managing servers. We just say, hey, I want a container running. Please give me a container running up in the cloud and I can connect to it, please. So yeah, it's running containers without servers. We don't need to manage VMs. We have really quick deployment. We can deploy via the CLI, PowerShell, and spin them up in the portal as well. And just note, where the second you spin these up for the second, you are being billed by the second. It's not expensive for a single container, but the idea being here is you don't want just one container, you'll have 10 or 100 or 1,000, and that's when the price starts adding up. So the options that we have with Azure Container Instances is we have the ability to either spin up Linux or Windows containers. Now, Linux containers are pretty much the ones that they're focusing on at the moment. Private networks, storage, container groups, those aren't available to Windows. They should be at some point, but for now, most of the options are for Linux containers only. The next point here, containers are exposed directly to the internet, is the default and was the only option up until a while ago. We now do have the option to spin up a virtual private network and run our containers in there, so we're not exposing our containers directly to the internet. I don't know if anyone's ever exposed SQL Server on port 143 directly to the internet, but bad things can happen. Okay, so we also get an IP address and a fully qualified domain name if we specify it. And Azure Container Instances give us, by default, a hypervisor level of isolation. Now what this means is when it comes to Windows containers, we actually have two different versions. We have Windows Server containers and Hyper-V containers. Windows Server containers are your pretty much typical containers. Hyper-V containers are actually running containers in a highly optimized, stripped-down virtual machine. So it's not making calls down to the kernel. It's all isolated within that one Hyper-V container. And that is the level of isolation that we are getting when we spin up an Azure Container Instance. And the final point there, we have persistent storage available as well for Linux containers only. Another concept with Azure Container Instances is container groups. Now these are similar in concept to Kubernetes pods. We have multiple containers all running on the same host, sharing an IP address, and the different containers within them are exposed on different ports. A way of thinking of this would be, say, an application container and a logging container. Application container, serving app requests, and inferring metrics and logging off to its logging container, which is then writing it down to persistent storage. But let's go ahead and create our Azure Container Instance. Now, we want to create our Azure Container Instance from our image that we pushed up to our Azure Container Registry. That registry is private, which means only the applications and people that we give access to can pull from it. Now, there are two different ways of giving access to your Azure Container Instance to pull that image from your registry. The first one is to enable the admin on your ACR and then show those credentials, write them down on a piece of paper, and we can drop them into our ACI creation script in a little bit. Okay, it's good for a quick demo, a quick proof of concept, but it's not the most secure way of doing things. Another way of doing things would be to create a key vault and store credentials that allow our ACI to pull images from our registry in it. So first thing to do is create a key vault. So we say Azure Key Vault, create in our resource group of containers 1, and then we give it a name, I don't know, Andrew Pruski test Key Vault 1. Not great at naming things, but hey. Create our key vault, and the next thing to do is store something in it. So the first thing we're going to do is we're going to store a secret that is holding the password of a service principal that has the ability to read from our ACR. And that's all this script is doing, is creating a service principal that has permission to pull the image from our registry, and then it's grabbing its password and storing it as a secret in our Azure Key Vault. So we have the password for our service principal. We also need to grab the username as well. So we can set a separate secret. So we're going to end up with a key vault with 2 secrets in it, one for the password and one for the user. So that's user there, just showing the service principal that we created and querying the app ID, and that's going to be stored as the username. So we have a couple of secrets that store information about a principal that has permission to pull from our registry. We can now use those to drop them into a create ACI statement so that we can pull that image and deploy it. So let's run through this statement here. The first thing we do is say Azure Container Create in our resource group of containers 1. Then we're specifying the image that we're pulling. So this is our test container registry, our dev SQL image, our latest, the image that we pushed up earlier. Then we're retrieving the username from our Azure Key Vault. So we're just saying Azure Key Vault secret show, the vault name, the name of the secret, and a query as well. Doing the same for the password. So when we spin up our ACI, we're specifying the credentials that we've just created so that we can pull that image. Next thing to do, give our ACI name, test container 1. Specify some resources available to it. Give it 2 CPUs, 4 gig of memory. And then we're specifying the environment variables. Same as when we spin up a container locally using Docker run, we have to accept the end user license agreement, and we have to specify an SA password as well. And then we're saying the IP address is going to be public. This was the only option available to us until recently. You can now spin up a virtual network and deploy into there. And now I'm going to specify the port that I want to connect to. I'm going to use port 1433, the default port that SQL listens on. So we hit execute, and then we can watch the status. So we hit Azure Container Show, name test container 1, and then we'll use the resource group containers 1, where we've deployed our ACI. It'll come back pretty much immediately with an IP address, but what we're looking for is a provisioning state of succeeded. Once that's there, we can drop that IP address into Management Studio or Azure Data Studio, and boom, we've connected to our instance of SQL Server, and hopefully our database will be there. Let's go ahead and let's spin up an ACI. So if I close these two down, got my script here, I'm already logged in. I can list my registries. There we go. I've got my repository as well. Great. Okay. Now we can spin up again. Now this is pretty much exactly the same script as we had in the slides. One thing I'm going to do is change it to the image that we just pushed up. One where we stopped our container with the database there, snapped it, and then pushed it up. Because I'm not confident that script is going to work because it was failing on me earlier. So let's grab all this and let's spin up our ACI. So that's going to go off, and that's going to start creating our ACI up in the cloud for us. If I let that run and create a new terminal here, I can monitor the progress of that just by doing an Azure Container Show, test container 2, and there we go. If I bring this up a little bit, we have our IP address pretty much immediately, but we're waiting for that provisioning state to change to succeeded. So let's have a look at one I made earlier. I have test container 1. We have our IP address here. State of succeeded, so I can jump over to Azure Data Studio, get rid of that, and connect here. Boom, and there's our database. Now this one was actually created with the initial script I pushed up that was running that attached DB script. The container came up, that script slept for 10 seconds, SQL came up, and then it ran to attach the database. I can do a new query here, let's just say version, I can type. There we go, and we have Microsoft SQL Server 2019 CDP 3.0. Okay, let's jump over to the portal Come back to our resource group, do a refresh. Oh, container 2 is coming up. If I jump into container 1, now I mentioned exposing SQL to the internet on port 1433. Generally not a good idea. If we have a look, we can jump into the containers, have a look at the logs. And yeah, this would be why it's typically not a good idea to expose it on the default port, because some person is trying to brute force their way into my Azure container instance. And that'll probably continue for the length of time that it's up. So if I was using these, I'd be deploying into a virtual private network, spinning up there and connecting either via a VPN or via a jump box into that virtual private network. Okay, let's go back and let's have a look to see if our other ones come up. Yes, there we go. We have a provisioning state succeeded, and we have our IP address here. So I can nab that, drop this into Azure Data Studio. Connect in. And there's our database. Of course it is, because that script didn't run. We snapped our container after we spun it up. So that database was already in the SQL instance when we pushed that image up to the cloud. But other than that, it's going to be in exactly the same container as the other one, the other ACI, pretty much exactly the same image. And we do an Azure version. There we go. And Microsoft SQL Server 2019 CTP 3.0. So that's how we can get SQL Server running with custom databases up in, say, Azure container instances. We didn't need to configure anything else. We just said, hey, I want a container with these resources built from this image. Give me my container, please. Oh yeah, we can also have a look at the logs here. So if I have a look at the logs of the other one, this will be interesting. We can pull out the SQL Server logs, and yep, there it is. Still trying to get into my ACI. I actually kind of hope they get in and just see one database there called database A that's empty. Okay, doing a bit of a cleanup. And we'll jump back into the slides. There we go. Okay, so that's Azure container instances, and those are really good for spinning up a container, testing with it, blowing it away. But what if we wanted something more permanent? What if we wanted to run SQL Server up in the cloud, say, in production? How would we do that? Enter Azure Container Services. This is Microsoft's offering to allow us to use an orchestrator to deploy and manage our containers up in the cloud. And we actually have two flavors of this. We have Azure Container Services, ACS, and Azure Kubernetes Service, AKS. ACS was released first, and it allowed us to choose our orchestrator. So we could use Docker Swarm, Kubernetes, Mesosphere DCOS, or if we're feeling brave, we could have built our own. Following that, Microsoft then released Azure Kubernetes Services, AKS. And Kubernetes really is the leading orchestrator out on the market. And as such, Microsoft are now deprecating Azure Container Services, ACS, and it's going to be gone by, I think, the end of January 2020. So Azure Kubernetes Services is really where it's at. If you don't know much about Kubernetes, it's a Greek word. It means helmsman or pilot, and the only reason I ever mention that is because it explains the logo. You'll also see it abbreviated to K8S, and then the simple fact for that is that there are 8 letters between the K and the S. It's open source, it's on GitHub. It was originally developed by Google. It came out of their Borg system. If anyone's read the Google Site Reliability Engineering book, it talks a lot about Borg. That is where Kubernetes came from. It's typically deployed as a cluster, so you'd have multiple servers running in your Kubernetes cluster, in your AKS cluster. It's a managed service, so you don't get access to the master. You can just deploy to the worker nodes of your cluster. So we take our container and we deploy it into Kubernetes. But we don't really deploy containers into Kubernetes. We deploy what is known as pods. Now, pods are similar in concept to what we talked about earlier with ACIs and container groups. The way I like to think of it is Docker, single container, group of Dockers, group of whales, pod, and that's all a pod is one or more containers running up in Kubernetes. Similar to container groups again, if you have more than one pod container in a pod, it will be listening on one IP address, and the different containers will be exposed on different ports of that pod. So we have SQL Server running up in Kubernetes, say in a pod. But pods in Kubernetes are mortal. They die and are reborn. And when they are reborn, they come up within the Kubernetes cluster with a different IP address. Now that poses a problem for us if we're connecting directly into those pods via their IP address. The pod will die, come up with a different IP address, we've lost our connection. This is where services come into play. Services give us a stable networking endpoint that we can use to connect to that routes our connection through to our pods. So we don't connect to the pods directly, we connect to the service and it routes our connection through. So those pods can die and be reborn with different IP addresses. We don't care, we've still got our connection. And the final line there is there's something called Coop Control, which is used to manage a Kubernetes cluster. It is the command line tool that everyone uses to manage Kubernetes. And there's loads of really cool plugins you can for it, but at the heart of everything is Coop Control. Now, I had to admit, when I first started looking at Kubernetes, I find it a little bit overwhelming. The documentation out there, and there's a lot of it, is really dense. If you want to know what a pod is, it will tell you. But what I really wanted to find was an entry point. How do I get started with Kubernetes? How do I just spin up a cluster and start playing around with it? And this is one of the reasons I love Azure Container Services, AKS, Azure Kubernetes Service even, is that you can spin up a Kubernetes cluster with one line of code. So one line of code, kick it off. It'll take about 15, 20 minutes because it's spinning up a lot of resources in the background. But once it's up, it's there, and you can start using to deploy to. So, said one line of code, this is it. We say Azure AKS create in our resource group of containers 1. Given our cluster a name, SQL Kubernetes cluster 1. How many nodes do we want in our cluster? You're going to go with 2. Typically, if you want to spin up things like AGs, go with 3 or 4. And then we can generate some SSH keys if they're missing on our local machine. Completely optional. And that's it. Hit execute, go off, make a cup of tea, come back, 15, 20 minutes later, your cluster will be up and running for you. We also have a nice, easy way of installing Coop Control with the CLI. We can say Azure AKS install the CLI, and that will download and install Coop Control for us if we don't already have it. Or if you install the Kubernetes plugin for Visual Studio, that will also install Coop Control for you. Okay, so now that we have our cluster, we need to get the credentials for it so that we can connect Coop Control on our local machine up to it in the cloud. So it's nice and simple. We just say Azure AKS get credentials of in our resource group of containers 1 of our cluster SQL K8 cluster 1, and that will pull the credentials down for our new cluster and merge them into the kube config file, and then we can be able to connect. And we can test that just by saying Coop Control get nodes. If all's gone well, we will be able to get some information back about the nodes that are running in our cluster. We've set up 2 here, so come back with 2 nodes. We've verified that we have connected to our Kubernetes cluster spun up in Azure. Okay, so we have our cluster up and running. Let's go and deploy to it. Now again, our ACR is private, so we need to give access to our cluster so that it can pull our image from our private registry and deploy it into Kubernetes. And I'm not going to use the key vault this time. I'm going to create a role to allow Kubernetes to do so. So the first thing to do is grab our cluster ID. So I'm going to say Azure AKS show in our resource group, our Kubernetes cluster, pull out the client ID and make a note of that. Then I'm going to get the container registry ID. So Azure ACR show in our resource group of name of test container registry 01, query ID. I'm going to make a note of that. And then finally, I can create a role assignment. So I can say Azure role assignment create, assignee, our cluster ID, role of reader, so it can pull that image from our registry, and the scope is going to be our ACR. To execute on that, wait for that to complete, and then we have granted our cluster the ability to pull our image from our container registry hosted up in Azure. So now we can deploy to Kubernetes. And Kubernetes got this really cool thing where we can use YAML files to define how we want our deployment to look like. So we don't have to say, I want to create this, I want to do that. We just specify what we want, push it into Kubernetes, and let Kubernetes sort it out. And so in this YAML file, first thing we're doing is specifying some metadata. We're going to give it a name and we're going to label the app SQL Server. Then we're going to specify the number of replicas we want in this deployment. Kubernetes has this concept of desired state versus running state. We are defining our desired state in this YAML file. And when we push it into Kubernetes, it then becomes our running state. And if there's any changes between that running state and the desired state, Kubernetes will automatically fix that for us. So what I'm saying here is in this deployment at any one time, I want one pod running SQL Server so that if anything happens to that one pod, please automatically spin me up a new one. So that's what I'm saying here. I want one at all times. Then we can spec out what we want in those pods. So the first thing is we specify a container. So we're going to say, give it a name, SQL Server 1. From the image that we've just pushed up, open in some ports, 1433 for SQL Server. And again, specifying the SA password and accepting the end user license agreement. And that's our deployment. We want one of those, one pod running one container with SQL Server from our image stored in our ACR. But remember, we're not going to connect to our pods, we're going to connect to our service. So we need to define our service. So first things first, specify a name, SQL Server service. Specifying some ports. Now what I'm saying here is the port 1433 on my service be mapped to port 1433 on my pod. So anything hitting the IP address of my service on port 1433 will automatically be mapped to port 1433 in my pod, and I'll be able to connect to SQL Server. And then finally, specifying a selector, which is going to identify the pod that we want to connect to, and then a type at the bottom there of load balancer. What this is going to do is contact the underlying cloud provider, Azure in this case, and say, I'd like you to spin me up a load balancer so I can get an external IP address that I can use to connect to Kubernetes from my local machine. So we have our YAML file. Let's deploy it into Kubernetes. So we just say Coop Control, apply or create, depending on which way you want it to do things. You can say apply or create. Create is usually specified when you're initially creating things, and then you can use apply to push any changes in, or you can use apply to start off. There are little differences, but for the initial deployment, you're okay. So we say Coop Control create -f SQL Server.yaml. Let that execute, and we'll see the deployment SQL Server created, and then we'll see the service of SQL Server service created as well. And then we're waiting for everything to spin up, and we can check on it by saying Coop Control get deployments, and we're looking here for a desired, current, up-to-date, and available all of 1. Get pods, we're looking for our name, status of 1 out of 1, and the status of running. And then finally, we're waiting for Coop Control get services. Now SQL Server service, type of load balancer, and this is what we're waiting for here, our external IP that we can use to connect from our local machines up into the cloud. Boom, so we grab that IP, drop it to Management Studio, and we're connected into Kubernetes, SQL Server running in a pod in our AKS cluster up in Azure. Final point as well, with Kubernetes, we also have a nice little dashboard that we can spin up that we can use to have a good overview of what's going on in our cluster. So we can see our deployments, our pods, our replica sets, we can see memory usage across the cluster, we can see CPU usage across the cluster. Really handy tool when it comes to just giving an overview of what's going on up in that cluster. Let's go ahead and let's deploy up into a AKS cluster in Azure. Okay, so I'm already logged in. I could get my credentials, but I've already spun these up, so let's test my connection to my cluster. And Coop Control get nodes. There we go. Okay, so I can connect to my cluster. I've got 2 nodes running in my cluster. I've created my role. So I'm going to set my location to my YAML file. I'm just going to spin that up as well. There we go. Exactly the same as the one in the slides. I'm going to use the dev instance latest. This is the one that's actually going to run the script. I'm getting a warning here. The Coop Control, the Kubernetes plugin for VS Code is really nice. It'll actually, you can hover over bits of the YAML file and it'll tell you what's happening with it. And what this is telling me is that I haven't specified any resource limits for my container. So if I deployed this to a Kubernetes cluster and I started hammering it, this pod could take all the resources of that node. So I might want to go in and put some resource limits in there, but for now I'm going to leave it as it is. Got my container, got my service. Let's go ahead and deploy that up to my cluster. Excellent. Okay, well, I can just clear that. Get rid of that. And let's have a look at those deployments. Excellent. Okay, so I've already got one up there running just in case this all went horribly wrong, but there's SQL Server 2 there. Desired, current, up-to-date, and available, all running. Have a look at the pods. That's good. Okay, SQL Server 2 up and running. I can pull out some more information about my pods. So I can describe them. I can see it here. I can see that it's pulled my image from my registry. It's created the container. It started the container, so it's all up and running. But now what we're waiting for is our service to get our external IP. And okay, it's already got its external IP. It's nice and quick. So let's grab that IP and let's drop this into Data Studio. Sometimes the external IP does come up before the internal networking is sorted, so let's see if we can connect. No. Oh, hello. Oomph. And there's our database. Excellent stuff. And do a query, make sure I'm not cheating. It is CTP version 3.0. Excellent stuff. Okay, so what we're going to do now is let's create another database in that image. So I'm going to come here and grab a notebook. One of the really cool features of Azure Data Studio that was released is SQL notebooks, where you can convert Markdown with SQL code. So I can do things like run this against, was that right? Yes. There we go. I can create my database. There we go. And I can confirm the database files. Remember right at the start, we set those environment variables for the default data and logs. So I just created my database and boom, it's dropped them into that location, the var ops SQL Server. Let's fire in some data as well, why not? There are 200 rows. Excellent stuff, listen. I'll close that. If we do a refresh, there's our database. Okay. Let's skip that a little bit and let's come here, get my pods. Just keep an eye on the time. Okay, so there's my two pods. 224 was the right, yes, good stuff. Okay, so I'm going to grab that pod name. And no mucking about, let's delete that pod. Come here. Now, what I've done there is I've basically changed the running state so it no longer matches the desired state. Kubernetes has already realized that and said, hey, the desired state of this deployment doesn't match the running state. I'm going to automatically spin you up a new pod so that they match again. Now, if we, that other pod should go down at some point. Will do. But we're not connected into the pods. Oh, hang on. Let's do that. Wide. There we go. There we go, it's lost its IP. I was going to show you that it did come up with a different IP address. I think it was 1.9 before. So the pod come up with a different IP address, but it doesn't matter because we're connected into our service. We still have our stable connection. So I can do a refresh here. But unfortunately, that database that we've created is gone. We haven't configured any persisted storage for our pods running up in Kubernetes. So any changes made that aren't in our container image will be lost if that pod is automatically, if that pod dies, sorry, and is a new one is brought back up automatically. So it's just something to be aware of. And when I say that data is gone, I really mean gone. There's no way I can roll this back. So configuring persistent storage for something like SQL Server when you're running a Kubernetes is an absolute must. But it's really cool to see that I can absolutely just kill a pod and it will come back up automatically back, and I've still got my connection here. Didn't need to do anything, I just refreshed it. I'm still connected in, even though that pod that came up has a different IP address. Do a bit of a tidy up. Okay. So that's the end of the session. Thank you very much. There's a link there on the screens to the resources on my GitHub for this session. That will link you to the slides and all the code for the demos that you can run through yourself if you want to check it out. If you have any questions, please feel free to ask. Thank you very much.
All right, thank you. And Andrew, we got a couple questions here in the queue, so we'll just kind of go through some of those real quick.
Sure.
We got a few minutes that we can do that with. The first one is a question regarding whether Azure SQL Containers is currently live outside of the East region.
Yes, you can use it in different regions. I've used it in a couple, but if you want to go for some of the more preview things, you have to use East US. I generally just default to it when I'm testing out this stuff, but if you go on the site, they'll tell you where everything's available.
And it's all outside GA, right? It's all generally available.
It is GA. There are certain features like the virtual private networks for ACIs that are still in preview, but ACIs in RGA, and so is Azure Kubernetes Service.
Okay. And then the next question is with your SQL Server instance that didn't deploy, do you know what the, why it didn't attach automatically?
It's something's happening with the script. It's happened to me on and off. For some reason, I think I might not be setting the sleep time. It might be too low. 10 seconds might not be enough for SQL to come up before the script executes the create database statement. I've never had a problem with it in AKS. It's ACI recently that's having that. I have to dig in more, but it was working in my demos yesterday when I ran through it, and this afternoon when I tried it, it just stopped working. So that's why I did the little workaround there to snap the container with the database already there and push it up, because otherwise I'd be spinning it up, showing you it didn't work, then spinning up another one to show you it worked, and we've only got an hour, so I just showed the workaround instead.
Okay. And I think the last question that we have here is can they have live migration demos from the Azure Kubernetes database? And I think that what they're asking there is if the scripts and all that will be available for doing that.
In my scripts?
Yeah.
Yeah, oh, absolutely. They're all on the GitHub just there on the slide. If you click on that link, if anyone wants that link there or wants to ping me on Twitter at DBA from the cold, or email me dbafromthecold@gmail.com, I'll send you a whole bunch of stuff.
Okay, and I got the question wrong.
Oh,
Sorry.
sorry.
Yeah, all on me for asking the wrong question. Can they have live migration from data migration service from Azure Kubernetes database?
I'm not sure what they mean by Azure's Kubernetes database.
So is it DMS service compatible?
I'm not sure, I'm afraid. Ping me an email on that one, and I'll follow up with whoever asked. Yeah.
Yeah, Karthik, if you can just the person that had the question was Karthik. Karthik, if you could just connect with Andrew offline, he can probably get that answered for you.
Yep.
With that, we have gone through all the questions that we had here. I want to thank everyone for joining today, and we will have another presentation tomorrow and on Thursday for the two that from the last two Thursdays we had some issues with. So thank you everyone for attending. Thank you, Andrew, for presenting today. This was an excellent session.
Thank you very much for having me.
All right, and goodbye, everyone.
Bye now.